Image formation by concave lens. So first is object kept between optical center and infinity. In this case, remember this lens always forms virtual, erect and diminished image. Diminished image. Guys, remember this. Concave will never form real and inverted, and convex will form both type of images. So this will always form virtual, erect and diminished image. Okay. So first case is object kept between optical center and infinity. So object kept between optical center and infinity. So infinity is somewhere we don't know about the distance, and optical center is there. So anywhere you can keep the object. So if you keep the object anywhere between optical center and infinity, you are going to get the same kind of image formation and same kind of characteristics. So light ray going parallel to principal axis, it will refract like this because this is a diverging lens. So you extend it backwards as if it is passing through the focus. It is not actually passing through the focus, but after extending backwards as far as passes through the focus, so you get an idea what kind of image it is going to form. Second, if the light ray is passing through optical center, it will go as it is. The point at which they are meeting, the image will form. So this is the image. So let me name the object as AB. So image will be A dash B dash. So if I write the characteristics of image formed, characteristics of image formed. Number one, you know that nature of the image will always be virtual and direct. So image is not upside down, it is not inverted. So inverted images are always real and they are always formed below the principal axis. So virtual and direct. Number two, about the location of the image. So you can write it forms on the same side as the object, guys. As the object, you need to understand one thing, that virtual and erect images are always formed on the same side as the object. This was the case in convex as well. Real and inverted images are always formed on the other side of the lens. Okay, so this is important. And number three, obviously it is going to be diminished. So anywhere you keep the object, anywhere, characteristics and the image formation would be the same. One more image formation for this, object at infinity. So if the object is at infinity, you know that object at infinity, image will be formed at focus. So straight line, mentioning that it is a concave lens. So this is f1, this is 2f1, taking my approximations, this is f2, this is 2f2. You know that object at infinity, light rays are going to come parallel, they will diverge as this is a diverging lens, diverge as it is a diverging lens, and they will pass through focus, So this will be the image formed. Again, characteristics are going to be characteristics of image formed. You know that first it will be virtual and direct because it always forms virtual and direct. Number two, you know it is going to be where the image is formed. You know that location of the image when object is at infinity, image formed is at f1, that is focus. And number three, it is going to be a diminished image. Okay, so these are the two cases for concave. Remember, concave always forms virtual, erect and diminished. And remember one thing, virtual and erect image always forms on the same side as the object, and real and inverted are always formed on this side. on the other side of the lens, that is towards right. Why I'm mentioning all these things to you? Because in the next class when we will discuss sign convention for numerical purposes, all these things you could relate there. So this is very important for you guys to understand it. Okay. So two cases are there. Object kept between optical center and infinity, and object kept at infinity. Alright. Thank you.